Good morning and welcome back. Yesterday we had learnt about Dobrynin's triads. The law was that he arranged the elements in an increasing order of atomic masses. But he had made groups of three. Each one was known as a triad. So it was known as Dobrynin's triads. And it was found that the atomic mass of the middle element was approximately the arithmetic mean of the other two elements in the same triad. But his theory later failed. So we are going to see even the drawbacks of the theory. What was the drawback of his theory? It was found that when the elements which were discovered later with higher atomic masses did not obey the law, and therefore his theory failed. Then we have the new scientist who proposed his theory, and he was John Newton. John Newlands, an English scientist who proposed his theory in the year 1866. He also used the same criteria as Dobrynin used. That is, he also classified the elements using the criteria atomic masses. He also arranged the elements in an increasing order of atomic masses. And he observed something that he proposed in his law, which is known as Newlands law of octaves. His law states that when elements are arranged in an increasing order of their atomic masses, every eighth element had properties similar to those of the first. First, we'll try and understand the meaning of the statement. He arranged the elements in an increasing order of atomic masses. That is, the element having less atomic mass comes first, and the elements having higher atomic masses follow them. He observed that every eighth element had properties similar to those of the first element. Let us see an example. Sodium is the eighth element from lithium, and both have similar properties. Sodium, the symbol is Na, comes after lithium because atomic mass of lithium is less and that of sodium is more. So it was found that sodium, being the eighth element in the series, had similar properties to that of lithium. Now his theory was also compared with the octaves of music. Let us see how. Comparison with 7 main musical notes. Now we have got two notations here. One is the Indian notation and one is the Western notation. In the Indian music system, there are 7 main notes. What are they? It is Sa, Re, Ga, Ma, Pa, Dha, Ni. And we again come back to Sa. Now this Sa, which comes second time, is of the double frequency. The frequency of the notes goes on increasing from Sa to Ni. And then comes the Sa again with the double frequency of the original Sa. It means that the notes repeat after completion of one saptak. As these are 7 notes, this is called as a saptak. So we get the repetition of notes after each saptak. With the Western notation also, the same thing was found. Here also we have got 7 notes, which starts with do, re, mi, fa, so, la, ti. And after the 7th note, we go again to do, which comes under double frequency. So similar to the octaves of music, his theory was similar, showing that every 8th element had properties similar to that of the first. The note do, having double the original frequency, comes again at the 8th place. This is the octave of Western notes. Now, we shall see the example in the form of a table. Newlands octaves. We have got the Indian music notes as well as the Western music notes. We start with hydrogen, then comes lithium according to the increasing atomic mass, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Now, fluorine is the 8th element in the series, which shows similarities with the hydrogen atom. Or we can take another example. Sodium, having similarities with lithium. Or for that matter, if we take magnesium, Mg, magnesium shows similarities with beryllium, and magnesium is the 8th element in the series. So this is how Newlands law is explained with this example. But children, when you see the table, in one place you can see 2 elements at the same place, that is cobalt and nickel, and one more table you can see selenium and lanthanide. There must be a question in your mind, how come there are 2 elements in this row? So let's explain that. This is the drawback of Newlands octaves. Cobalt and nickel are occupying the same place, and if you see the table, hydrogen, fluorine, chlorine and bromine. As we all know, fluorine, chlorine and bromine are halogens. Then cobalt and nickel will not have similar properties to halogens, and yet they are coming in the same table. So this is the drawback of Newlands octaves. That is, here, even if it is the 8th element, they do not obey or they do not show the properties similar to the halogens. If you see the other group also, the one which is highlighted here, selenium and the lanthanide, again we have 2 elements occupying the same place, and their properties are not similar to the others which are found in the same group, that is boron, aluminium, etc. So this is the drawback of Newlands octaves. Many limitations were found in Newlands octaves. This law was found to be applicable only up till calcium. Newlands fitted all the known elements in a table of 7 into 8, that is 56 boxes. Totally he made 56 boxes. He placed 2 elements each in some boxes to accommodate all the known elements till that time. For example, cobalt and nickel and selenium and lanthanide. Moreover, he placed some elements with different properties under the same note in the octave. For example, Newlands placed the metals cobalt and nickel under the note Do along with halogens, that is fluorine, chlorine and bromine, while Fe, that is iron, having similarity with cobalt and nickel, away from them along with the non-metals oxygen and sulfur under the note T. Here you can see oxygen and sulfur. Iron is placed with them where the properties of iron do not match with the non-metals. Also, Newlands octaves did not have provision to accommodate the newly discovered elements. When elements were later discovered, they did not have place in Newlands table. The properties of the new elements discovered later on did not fit in Newlands law of octaves. So, we'll just revise what we have just learnt. Newlands law of octaves states that when elements were arranged in an increasing order of atomic masses, every eighth element showed properties similar to the first. But it was found true only for few elements and did not follow for the elements which were discovered later. And that is why his theory failed. Thank you.